What's going on, everybody? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video course. And in this video, we're going to finish up our inter-VLAN routing labs and lecture. So for our paid customers or paid students, this EVNG lab repo or folder right here, CCNA video course, is available to you. And we're going to go in here to section 4, and we're going to go to our SVI lab. So for our students watching this on YouTube or any free streaming service, all the lab information is available to you again via these videos or on our GitLab, which should be posted in the description below. You can see here, if we come here to section 4, instructions, SVI lab, you'll have the network diagrams. You can rebuild it yourself, and also the instructions. And then we also have baselines for you to use. So I'm going to pull this GitLab over on the right, and I'm going to look at my instructions on a monitor that is not visible to you guys. And I'm going to go through our lab instructions. So step 1 is going to be turn on all devices. So in EVNG, we're going to come over here to more actions and hit start all nodes. And now while these are starting up, let's go over this lab, right? Not actually going over the instructions. Let's just go over what we're doing, right? So in our last video, we went over router on a stick. And in this series of videos, the whole point of what we're teaching is how to get our logical layer 2 segmentation using VLANs to be able to have IP or layer 3 reachability. So what do we mean by this? Well, we know that VLAN 10 and VLAN 20 are their own broadcast domain. They're their own network, right? At layer 2, they're segmented by an 802.1q tag. And if these two tried to ping, it would be no bueno, right? Because they're separated. So to get these VLANs to be able to talk, we need a layer 3 device to be able to route traffic between these subnets, right? So what do we do in this lab? So instead of having a physical router and creating logical subinterfaces, what we're going to do here is create a multi-layer switch, and I have it DSW1 for distro switch, right? And this layer 3 or multi-layer switch is going to be our layer 3 device that does our routing. So what we're going to do here is we're going to create interface VLAN 10, 20, and 30 on this distro switch 1, and that's going to act as the router and do the packet forwarding for all of our VLANs here. So if we added another VLAN, let's say VLAN 40, and that was IP address 192.168.40.0/24, we would have to create another SVI on this distro switch so that that VLAN can be part of this routing domain, right? So instead of creating sub-interfaces, now we're just creating SVIs on our distro switch. So because this distro switch is acting as our router, does that mean that these VLANs need to be, or the SVIs for these VLANs need to be created on our access switches? No, they do not. Because this is acting as our gateway out to the internet and as our routing device internally in our LAN. So we only need to create SVI 10, 20, and 30 on distro switch 1. So with that being said, now let's jump into our lab. So step 2 is paste baseline from GitLab. And before we can do that, let's go ahead and console into our devices. And let me get rid of these tabs I was using in my last video for router on a stick. Okay. Now, step 2 says paste baseline from GitLab. So for our paid viewers, this will already be done for you. If you download the labs from our central repository. For everyone else, we are going to have to go into our GitLab and paste our baseline. And as you can see here, I don't think that I actually saved the configuration here. Let's see here. Show clock. Nope, I don't think I did. Let's just do that show run again. So we want to do configuration from scratch, okay? So let's go ahead and do that. So the first thing we're going to do is paste baselines. So try to Control-Shift-6 out of that. That does a hotkey for my pen, apparently. So let's go ahead and get our baselines here. So I'm just going to come to our GitLab repo and grab our baseline from there. And I'm going to paste them in. And the only thing I'm going to change is our host names. We're going to paste. Come over here to switch 3 and do the same thing. And then switch 4, we're going to do the exact same thing and just change that name. Awesome. And then we're going to do the commands that are not part of this lab, but we need to do it. And if we went to our next step, verify all the trunks and VLANs are created/assigned, you would see that that configuration isn't done yet, so you have to do it on your own. So for distro switch 1, we're going to type in interface range ETH01 through 2, switch port. Let me bring this into a better view. Trunk encapsulation.1Q, switch port mode trunk, and then switch port no negotiate. And then I'm going to go into these individual interfaces, and I'm just going to do a description. So this is going to be trunk to switch 3, and then interface 02, description, trunk to switch 4. If you guys are wondering how I know just off the top of my head where these physical interfaces are going, well, one, I made the lab, right? But in the actual Git repo and these instructions, you have a network diagram here that I'm just looking at on my extra monitor. Okay, now let's go into switch 3. We're going to do the exact same thing. So interface range ETH00 through 1. Switch port trunk encapsulation.1Q. Switch port mode trunk. Switch port no negotiate. And then we're going to go into the individual ones and just give them a description. So trunk to switch 4. And then Ethernet 01 is trunk to distro switch 1. Awesome. And then we're going to make our trunks here as well. Interface range 00, comma, ETH02, switch port trunk encapsulation.1Q, switch port mode trunk, then switch port no negotiate. And again, we're going to do our descriptions because we like good documentation, right? Yes, we do, because the network engineer admin coming in behind us wants to quickly know what he or she is dealing with. So now that we've done that, let's go ahead and make our VLANs. So we have VLAN 10 for sales, VLAN 20 for engineering, then VLAN 30. That's going to be our management of our network devices, right? And then let's go ahead and assign these VLANs. So Ethernet 01 is going to be in VLAN 20. So VLAN 20 engineering, switch port mode access, and switch port access VLAN 20. And then we're going to put this in spanning tree port fast, which we learned earlier in this video series, right? That turns off spanning tree and brings our ports up right away. Do the same thing for ETH00 or 03. That's in our VLAN 10, our sales VLAN. Switch port access VLAN 10, and then spanning tree port fast. And then switch 3, we're going to do the exact same thing. So we're going to do interface ETH02. That's going to be in our sales VLAN 10, switch port mode access. We'll do the shortcuts here. And then spanning tree port fast. You can see that I didn't actually name the VLANs yet. That's okay. It's going to work without giving the name. It's just bad documentation. But we're going to go ahead and do that as well. VLAN 20 engineering. Switch port mode access. Switch port access VLAN 20. And then we're going to do spanning tree port fast. We're going to get out of here and go ahead and name our VLANs. VLAN 20, name is engineering. And then VLAN 30, name management. Awesome. Whew. So now let's get back to the actual lab itself, right? Creating these SVIs. So if we go back to step 3, now we can verify our trunks, which show interfaces trunk. Okay. We can type in show VLAN brief to make sure our VLANs are assigned correctly. And they are. Do show VLAN brief. Yep. And now, step 4. Create all the necessary layer 3 SVIs on the distribution switch. So at our distro switch here, what we're going to do is create each one of these interface VLANs. So there's one step we haven't done here on this switch, and I'm just going to go through like we already have. We haven't created the layer 2 VLAN yet. So I'm going to show you, right? We're going to go through this whole lab and come back and do it at the end to show you how it shouldn't work, right? Because we don't know what VLAN this interface VLAN 10 should be a part of, because we haven't created VLAN 10 yet. So we're going to go through like we did, right? We're going to see that we shouldn't have connectivity because we need to create that layer 2 before we can have layer 3 connectivity, right? Yes. So no shut interface VLAN 20, and I had to give these IP addresses as well. 8.20.1. Interface VLAN 10, we have to give it an IP address as well, 192.168.10.1. And the reason I'm going through these labs quickly like this, guys, is because every command I'm typing, if you're watching these videos in chronological order, you should already know these commands. I'm just assigning IP addresses, right? Only the concepts are new. The actual command syntax is not, right? You've been watching me put descriptions ever since the very first lab, right? And assigning IP addresses we've been doing this whole time as well. So now that we've created our SVIs, let's go back to privilege mode and let's take a look at our interfaces. So you can see that these VLANs are down. These interface VLANs are down. Now, why is that? Because we haven't created the actual layer 2 VLAN tags, right? Or this switch doesn't know that there's VLANs out there to be a part of this network. So we got to go ahead and create them. So VLAN 20, name engineering. VLAN 30, name management. And now if we exit out, we should see those SVIs come up. If not, we'll go ahead and flap them ourselves. And then let's go ahead and test reachability, right? So while we wait for that, we're going to come to switch 3 and 4, and we're going to create interface VLAN 30, right? Because we also need to have the ability to do management on our access switches. We're going to do this on switch 4 as well. Interface VLAN 30, IP address 192.168.30.3. No shut, and then the other command is IP default gateway 192.168.30.1. We're going to do this on switch 3 as well. IP default gateway 192.168.30.1. Awesome. Now we come back to that distro switch. Okay, we saw VLAN 20 and 30 come up. Now, another thing we have to do on this switch is it's going to be our router, right? We actually need to enable routing on it. So we do that with IP routing. And what this is going to do is actually give us a routing table in this switch. Because at the end of the day, this switch has to route our traffic out to the internet. So we got to give it that routing functionality, or at least tell it, hey, you're going to be a router. So if we get rid of that command, you can see we don't have a routing table anymore. But now we enable it again, do show IP route, there's our routing table, okay? So now this distro switch is ready to do some IP routing beyond just its local area network. Okay, now let's just test reachability between these switches without going to the users. Now we can, right? But as network admins, we like to do a lot of our testing within the CLI, right? Because we're not always on the phone with the user saying, okay, ping this or ping that, especially if we're remote, right? Now, we could potentially remote into maybe a computer we have in a data center or something to do tests from a PC. But again, we like to test our reachability on the network. Because if our network is good and the PCs aren't, maybe we, route that ticket a different way. So how do we test inter VLAN routing from switch 4? So we know that switch 4 has interface VLAN 30 created. So we can test to see if interface VLAN 30 can actually ping, let's say, VLAN 10. So let's try it, right? And the first test we're going to do is just make sure we can reach our own default gateway. Okay, we can, and we missed a ping, and that's of course because of our ARP, right? But now our ARP table's built. So let's see if we can ping VLAN 10. We can't. And that ain't just ARP. That hotkey, Control Shift 6 gets you out of like ongoing tasks going on in your CLI, but it's also a hotkey for my pen, I guess, my pen application. Gonna change that after this video. So now let's see if we can ping VLAN 20. So we saw that VLAN 10 subnet was unreachable. Now let's see if that's just an error with VLAN 20 itself or something's wrong with our inter VLAN routing. Okay, we also can't reach VLAN 20. So this is probably a good indicator that maybe something's wrong with our VLAN routing, right? Let's go back to distro switch 1. Let's go ahead and look at our SVIs. So we should be able to reach VLAN 20. Let's see what the issue is, and we're going to actually go ahead and do a Wireshark if we can't figure out the problem, right? If we can, oops, we meant to do that. We want to go to 30.3, and we want to source it from VLAN 20. I was just pinging myself. Okay, so what could possibly be the issue here? So we have our distro switch here, which should be able to do should be doing inter VLAN routing. Switch 4 has interface VLAN 30 here, but it cannot reach VLAN 10 or 20. When we ping .30.3, we can reach it. We can reach our other switch on the other side, but we can't reach it when we source it from different VLANs. So what could possibly be our issue here? So one thing we're going to check is make sure that these interfaces are configured correctly. So we're going to go show run interface VLAN 20. Okay. We know we've enabled routing. So let's just go ahead and create a VLAN for VLAN 10. Or let's go ahead and create VLAN 10, right? Okay. Now, let's see if we can do that ping to our switch 4 source from VLAN 10. So it's still down. So we can commuter interface VLAN 10 and just shut and then no shut, make it a little quicker. Now it's up, and now we can try that ping again. And no good. So what could possibly be our issue here? So sometimes I've seen it in switches. Sometimes it depends on the iOS as well, where if that VLAN isn't assigned to like a physical interface, we're not able to do routing for it. Now, I know that sounds weird, but let's just go ahead and test this theory out, right? So on our distro switch, we have Ethernet 03 available. So we'll go switch port mode access and then switch port access VLAN 10. Then we got interface 10. We're going to do the same thing. Switch port access VLAN 20. Let's go ahead and take a look at our ARP table here, right? So we know about these, and we know where we should be sending them. So let's try this one more time. So let's try to ping 30.3 source VLAN 10. Nothing. So let's come back to switch 4 here. Let's see why we're unable to. Let's see if we enable routing on here. Let's see if that does any difference for us. Okay, now let's just go ahead and do some inspection here. We want to look at ETH02. Let's try that ping one more time. So we don't even see that ping coming across. Now, if we come to distro switch 1, let's try that. So we see that ping, but it looks like the switch itself is not receiving that. Now, what could potentially be the issue here? Well, at switch 4, what's happening here is at the layer 2, I believe it's not able to receive that encapsulated frame. Because if we look right here at that ICMP message from distro switch, it's being encapsulated with VLAN 30, but the source should be IP address belonging to VLAN 10. So we really can't get reachability between the two testing these VLANs. So let's see if our PCs can, right? So PC 8 should be a part of VLAN 20. So what we're going to do is type in 192.168.20.2/24. Then 192.168.20.1 is the default gateway. Then PC 7. Actually, let's go into PC 6. Actually, no, PC 7 will work. On the same switch, doesn't matter. Give it an IP address, 192.168.10.2/24, and default gateway 192.168.10.1. And let's see if we can ping our default gateway. We can. And let's see if we can ping VLAN 10's default gateway. We can. If we come back and look at our Wireshark capture here, the reason this is now working is because they're being encapsulated correctly. So the issue before, we looked at those pings that weren't working, they're going to be way up here, is we were trying to ping a VLAN 30 IP address sourced from a VLAN 10 address, but at layer 2, it was encapsulating it with VLAN 30. That's obviously a no-go, right? So it doesn't mean this switch doesn't have reachability. It just means that from layer 2 switch to distro switch, we're not going to be able to have reachability between VLANs because this switch isn't necessarily acting as a client. And when this switch pings that from source VLAN 10 to VLAN 30 on this switch, when it receives the frame, it doesn't know how to decipher it because it says, okay, this is a ping from VLAN 30, but the IP address is in VLAN 10. That's the source. So it's not understanding what's happening on the wire, right? But as we can see, we do have inter VLAN routing capabilities. So I guess we learned something here together, right? And this could just be an even G-ism, right? That's messing this up, but that's okay. Now we can kind of, during these labs, I'm not going to go back and edit this, right? It's good that we can figure out how or what's going on our network by doing Wireshark captures and looking at the actual packets coming out. So, okay, awesome. So that's inter VLAN routing. I hope this video was informative, and please continue to watch and support our channel, guys.